All right. So in this simulation here, we have a relay K, and this relay K is connected over to a normally closed contact. And then this normally closed contact, basically what it's going to happen to allow current to flow because we have a AC generator right here. Current should flow through here because it's closed. You can see that's closed. I can even move it up a little bit. There you go. It's closed. And this is without K being on, so it comes this light should light, which it is. It's light. So if this relay K kicks on, this coil should go from a normally closed to a normally open. So what I did is I took a multimeter, what I call Agilent multimeter, connected my probes to it, and I'm just going to move this probe, so this probe's up there, and then I connected it across. Now, one thing that should happen is if I close the switch, I should get a voltage across here, across K. So let's see what happens here. So my meter's on, it's DC, so if I actually press A, that light over there should turn off. This light, X1, should turn off. Let's see what happens. So if I take that, notice that nothing happens. This is still saying lit. This is still normally closed. That means the relay K, something's wrong with relay K. So there could be a couple problems with relay K. Number one is we could actually have an open. Well, if it wasn't open, this multimeter should read source voltage, 10 volts. Well, we know the relay has to be good then. All right. Second thing is we could have a problem with the battery. Well, let's assume that there's nothing wrong with the battery. So let's say that we are looking into, and then we look into the specs on this. We look into the specs of this relay, and we find out that if I actually double click on it, it actually gives you down here. But let's say we open up the specs on it. So I double click on this relay, and it tells me that the coil is inductance is 1 millihenries. The resistance of the coil is 300 ohms, and the pickup current is 50 mils. Well, let's do some math here to see what happens. Using this information, we can actually figure this problem out here. So if I actually come over here and I take, well, V is equal to I times R. So if I come over here and I come over here and I get my calculator and I take 50 mils. Well, 50 mils is 1, 2, 3, so it's 0.050. That's 50. 1, 2, 3. And I multiply that by 300 ohms because V is equal to I times R. I have 15 volts. That means I need 15 volts to operate this coil. Guess what I have here is 10 volts. Time to increase the voltage on. So I'm just going to double click on this. Put 15 in. Hit OK. Now let's see what we have. So if I actually run on here, and what I'm going to do is hit A, and then I'm going to press it. There it is. Light goes off. Coil's working. So our problem here is the voltage. So when you're working with a coil, a lot of times what you have to do is pay attention to the specs on the coil, on the relay coil. And what you want to do is remember on the relay coils that you have 2 large terminals, which is your power, and then you got a couple smaller terminals. It could be 6, it could be 8, it could be 20. It doesn't matter. So what you want to do is just look at the specs of the relay of itself. Okay. If the other problems that we can have in relay is, let's say the voltage was fine. Let's say the voltage was fine. We measured across it, and we were working, but it was not causing my contacts to switch. Well, then we can actually have a problem with the magnetic field generated by the coil. We can have a problem with the contacts. There could be a problem with the spring. So in short, we need a new coil. So I hope that helps you understand a little bit about how to troubleshoot a relay. We'll talk a little bit about this on week 5. Thank you.